Good morning, good afternoon, good evening, and good night, everybody. Welcome to IB Buddy Grade 9 Science, Climate Change, and Ecosystems. Don't mind my voice. I right now have a sore throat and a stuffy nose, but you gotta keep the grind going. So today we're covering climate change, but not just what it is. We're going to be covering why it's happening, what the evidence is, and who's actually responsible. There's three parts: climate cycles, evidence and impacts, and societal implications. Let's go. So, first thing, your friend says climate change isn't real because weather is supposed to change. We have seasons after all. Is that really a fair argument? So to answer that, let's first go over weather versus climate. So here's the key difference. Weather is what's happening outside right now. It changes every day. Climate is the overall pattern of weather over decades. So when we say Ontario has cold, snowy winters and hot, humid summers, that's climate. But that doesn't mean every single winter day is snowy. Climate change is about those long-term patterns shifting, not just a random cold day. So let's answer the question, is climate supposed to change? And here's where it gets interesting. Yes, actually, the climate has always changed naturally, but that doesn't mean what we're experiencing right now is natural. Let me show you the three types of natural climate cycles. So, number one, millennial cycles. So, those are 10,000 to 100,000 years. And so the first type is millennial cycles. These are massive, slow changes caused by shifts in Earth's orbit around the sun. As the orbit changes, the amount of solar radiation Earth receives changes, which triggers huge glacial periods, ice ages, and warm interglacial periods. The last ice age ended about 12,000 years ago. These cycles play out over 800,000 years, so they're extremely slow. The second type is century cycles. So that's between 200 to 1500 years. So there are shorter cold and warm periods, sometimes regional rather than global, and possibly caused by changes in ocean circulation. Two examples are the medieval warm period from around 900 to 1300 AD and the Little Ice Age from 1450 to 1900 AD. Now let's talk about the third type, interannual / decadal cycles. So these are 3 to 7 years long, like cycles. The third type happens over just years or decades. The most famous example is El Niño, every 3 to 7 years. Part of the Pacific Ocean warms and cools in a cycle that affects weather patterns all over the world. You've probably heard of it in the news. Now, here's a concept that connects all these. So let's first draw a circular loop. This will be is called the feedback mechanism. So inside we're going to write more solar radiation. That leads to ice melting, which leads to less albedo, which leads to more heat absorbed, which finally leads to temperatures rising. A feedback mechanism. This is when a small change triggers a chain reaction that amplifies itself. So like this, increased solar radiation melts ice. Less ice means less albedo, and albedo is how much sunlight a surface reflects back. Snow and ice reflect a lot of sunlight, and ocean water absorbs it. So less ice means more heat absorbed, which means more ice melts, which means even more heat absorbed. A small push becomes a runaway process. Now let's look at evidence and impacts. So if climate is supposed to change naturally, why are scientists calling this a crisis? So to explain this, let's first draw a graph. So this is time and this is temperature. So let's make this line expected natural change. And now this other line is the actual recorded change. Scientists can calculate what temperatures should look like based purely on natural cycles. When you compare that expected line to what's actually being recorded, they don't match. The actual temperatures are spiking way beyond what any natural cycle explains. That gap is caused by human activity. The climate has always changed, but not this fast. So let's first draw Earth. Boom. And then we have like planets, or planets. We have continents, and then our oceans. Boom. And then let's fill in the green for our continents. And then let's draw a layer, a little layer around the Earth. So let's just call the pink the atmosphere. And then let's draw a sun over here. So the sunlight goes into the Earth. And then obviously it reflects back, but because of the atmosphere, it can't escape. So it just keeps going into Earth and heating up Earth as a whole. So here's why climate should not change this fast. The greenhouse effect is natural and necessary. Without it, Earth would be freezing cold. Greenhouse gases like carbon dioxide, methane, and water vapor trap some of the Earth's heat inside the atmosphere like a blanket, as you can see here. But when we pump extra greenhouse gases in, the blanket gets thicker and traps more heat than the planet needs. So some evidence of climate change. Number 1, CO2 levels rising since the Industrial Revolution. Number 2, there's also temperatures higher than natural cycles predict. And then number 3, more frequent and severe natural disasters. And then lastly, increased health issues globally. Here's how we know it's actually happening, climate change. CO2 levels, carbon dioxide levels, measured in ice cores show a dramatic spike right after the Industrial Revolution, when factories started burning fossil fuels at scale. Temperatures are tracking above what natural cycles predict. Natural disasters like floods, droughts, and wildfires are becoming more intense and more frequent, and health impacts are increasing. By 2050, an estimated 250,000 extra deaths per year are expected from heat waves, malnutrition, and disease linked to climate change. Now let's draw a web. So climate change, and then we have outside parameters. Let's have water quality. We also have air quality. And then we also have food supply. And then also natural disasters. And we also have health. And notice how everything connects. Warmer temperatures affect water quality, create air pollution, destroy farmland, trigger more extreme weather, and cause disease. It's not one isolated problem. They're all linked. Now, part 3. Who is responsible? Now, the most important question, who is actually causing this? So, the average Canadian household, let's talk about that. So, they contribute to 4,100 kilograms of greenhouse gases per year. You might think individual choices are the main driver. The average Canadian household produces about 4,100 kilograms of greenhouse gases per year. That sounds like a lot. And then also, the Canadian transportation sector. They produce, this is going to be a huge number, it's 169 billion 300 million kilograms of greenhouse gases in 2018. But the Canadian transportation sector alone produced this much greenhouse gases in 2018. That's 169 billion 300 million kilograms. One household produces 0.000000024% of what just the transportation industry alone produces. It would take the average household over 41 million years to match that. So 100 companies equals 71% of all global industrial greenhouse gas emissions. And zooming out globally, just 100 companies are responsible for 71% of all industrial greenhouse gas emissions on the planet. That is an insane concentration of responsibility. But can we just shut them down? Now, you might say, well, let's just eliminate those industries. But in 2018, the Canadian transportation and warehouse industry alone employed 920,000 people. Almost 1 million families depend on those jobs. So solutions have to be more nuanced than just shutting everything down overnight. To explain, let's have two stick figures. We have this is the high income country. And then we have this one, which is the low income country. So here's the part that makes this quite unfair. The people whose health is being harmed first and worst by climate change are the people who contribute the least to causing it. Wealthier people and wealthier countries produce more emissions, and they also have more resources to deal with the consequences. They can afford to move, buy better healthcare, adapt their homes. People in lower income countries often cannot. The ones creating the problem are the most protected from it. So let's pretend this is the Arctic, two versions of the Arctic. So this one has a lot of ice. Let's just pretend this is a lot of ice, and then that much. So that is the Arctic then versus now. A real example. The Inuit people live in the Arctic and depend on marine animals like polar bears and harp seals for food. Those animals need sea ice to travel, hunt, and raise their young. As the Arctic warms faster than anywhere else on Earth, that ice is disappearing, melting, because of the heat. The Inuit didn't cause this. They're among the lowest emitters of greenhouse gases on the planet. But they're losing their food systems, their culture, and their way of life because of emissions produced mostly by industrialized nations thousands of kilometers away. Let's talk about environmental stewardship. So what do? The concept is called environmental stewardship, taking personal and collective responsibility for caring for the environment. That means both pushing for systemic change at the corporate and government level and making smarter individual choices where we can. Remember, even a 1 to 2 degree average temperature increase can trigger feedback mechanisms that spiral out of control. Small changes add up in both directions. So to wrap up, climate has always changed naturally through millennial, century, and interannual cycles. But what we're seeing now is happening way faster than any natural cycle explains, driven by human industrial activity. The evidence is in rising CO2 levels, carbon dioxide levels, spiking temperatures, and increasing natural disasters. The responsibility sits mostly with large corporations and wealthy nations, but the consequences fall hardest on those who did the least to cause it, including indigenous communities like the Inuit. And the response has to include both systemic change and environmental stewardship at every level. This is IB Buddy Grade 9 Science, and I'll see you tomorrow.